Okay, let's explore prisms. Now with a prism, we start with a base shape, and then what ends up happening is that base shape ends up being extended back, okay? And it creates this three-dimensional shape, okay? But this base shape is the one that we are considering first, okay? So let's look at something like a triangle. So the triangle would extend back, okay? And the rest of the shape creates a series of rectangles, okay? But the base shape at the front is maintained. So in other words, if we took one of these shapes and we just sliced through it like we're slicing through bread, this base shape would always be at the front. Now, what this means is when it comes to finding the area of these shapes, what we're doing is we're finding the area of this base shape. So for example, in this case, it'd be a triangle. Find the area of the triangle, and then you're just multiplying it by the distance that we see here in the depth of the particular shape. So in this one here, you'd find the area of a rectangle and then multiply it by the depth. If you're doing something, for example, like a pentagon, it's a little bit harder to draw, you'd find the area of the pentagon, and then the pentagon image would just be back behind, and you'd multiply it by the depth of that particular shape, okay? We know it's half base times height, okay, to find the area of the triangle, and then we're going to multiply that by that depth, okay, by that depth. Okay, so that's the bit of information that we need to know. Okay, so we've given some dimensions to our prism here. So what we want to do is we want to find out the area of a triangle firstly. So it's half base times height. So that gives us, this case would be 6 multiplied by 2 and all over 2. And then we're going to multiply that by the depth of this shape, okay? Now, sometimes if the shape is standing upright, like a silo, like a tall building, it might be multiplied by the height of that building, okay? So sometimes you'll see some of these words being used in other contexts. And the depth here on this one is 4, okay? So once we can multiply that out, so 6 times 2 is 12, divided by 2 is 6, and 6 times 4 equals 24, and here it's meters cubed rather, not squared, cubed, okay, for the volume of that particular prism. Okay, so we can summarize this as saying if we take a shape like this, we're looking at the volume of it is going to be equal to area times height, okay? So the area in this one is the area of the base shapes. In this case, it would be a hexagon. So the area of a hexagon, and we could then multiply that by the height, or in this case, I would call it the depth, okay? And which is this distance here on the particular shape. So this rule is then applied to all of the other rules. You just substitute in for the A, the rule that applies to that particular shape. So if it was a rectangle, it would be length times width. If it was a triangle, it would be half base times height, etc., using your other rules. And this is where your formula sheet will be of assistance to you to access those rules and apply them as you see fit. Sometimes we're given an irregular shape as our base shape. So here you can see here we've given this quite irregular shape, okay? And it's been extended down, okay? Put a line there to show that that's a to make a three-dimensional shape. Now, in these instances, you will be given the area of that particular shape, okay? Because we don't have an area rule that allows us to calculate that on its own. But the same theory applies in terms of volume. We take that area, in this case it's 20 centimeters cubed, we put that in here where the area of that is, and then you would just find out what the height of this shape is. Let's say that it's 40 centimeters. Okay, let's say that that's the height of it, and then you just multiply that by the height, and that would give you the total volume of this particular irregular prism.